Okay, so this is section 2.2b. We're skipping 2.2a. Um, in this section, you're going to write rules for linear patterns and connect that rule to a pattern. This is called a geometric model. You're going to understand how a linear relationship grows as related to a rate of change and show how you can see that rate of change on a bunch of different representations. Um, we're going to create those representations, which are a table, a graph, equation, and a geometric model of a linear relationship. And we're going to make connections between all of them. And then we're going to identify the rate of change and initial value of a linear relationship from those representations. All right, let's get going. So in part A here, you see these arrangements of blocks. We want to figure out how many blocks are added from one stage to the next. Here's stage one. We started with just one block, and then these two were added, so we added two. So now this is stage one, and from stage one to two, two more were added. And then from stage two, this is what it looked like in two, and then two more were added. So two blocks are added every time. So if you look at stage one, you have a total of 1, 2, 3 blocks. If you look at stage two, you have a total of 1, 2, 3, 4, 5 blocks. And then stage three, you have a total of 1, 2, 3, 4, 5, 6, 7 blocks. So tell me what's happening from here to here and here to here. Well, you're adding 2 every time. And as long as you go up by ones here, you can continue to add those 2's. Whoops. So 7 plus 2 is 9. If you add 2 more at stage 5, then we're at 11. So this should be 3, 5, 7, 9, 11, adding 2 every time. So where do you see the rate of change on your table? Well, that's right here. You're adding 2 every time. Remember, this is your X and Y, so that is the change in your Y values. Okay? So now, let's make a graph out of this information. Okay? So I guess we're still going to make this X and Y instead of S and T. So your stages are here on the X-axis, and your number of blocks is on your Y-axis. So I think we're going to take a peek at the numbers and go up by ones, but I'm going to skip every one. So I'm going to skip this one. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I only did that because my writing's too big to squeeze in there. You can label every one if it helps you. All right. So at stage 1, I have 3 blocks. So at stage 2, I have 5. At 3, I have 7. At 4, I have 9. At 5, I have 11. If you notice, this no longer starts at 0. Like, we no longer go through the origin, so this is not proportional. In order for these graphs and these relationships to be proportional, they have to start at 0. Okay? So we started with this one block. We did not start with no blocks. We started with one block. So this is not proportional. Okay? So let's write an equation for this. This would be E for you. What is an equation that gives the number of blocks T for any stage S in this representation? Where do you see the different pieces of the equation in the geometric model? Okay, so let's go back. There's one thing missing from this table that I'm going to fill in. At stage 0, we started with this one block. Okay, so our equation is going to be in this format. So M is going to be your rate of change, and the B is called your y-intercept. I call it the starting point. It's where you start. Okay, so if we look on the table, here's our rate of change, or our M right here, because adding 2. If you look at the graph, you're going to go up 2 over 1, up 2 over 1, up 2 over 1. So that's your rate of change, and it replaces the M. So you have y equals 2x plus, now your starting point can be found right here, or look at your graph starts at 1, positive 1, so that'll be 1. This is how you make these equations. We're going to get a lot of practice with this. Okay? All right, so let's look at F. The pattern above is linear. Describe how a linear pattern grows, and describe what the graph of a linear pattern looks like. Well, it grows, linear patterns grow at constant rates. And in this case, it's 2. Adding 2, the graph goes up by 2, so they grow at a constant rate. All right? So then the graph will always be a line. All right? So the pattern is linear. It makes a line. Let's look at a different pattern here. Let's look at number 2. Okay, we start with 1. So at stage 1, you have 1 block. Keep your eye on this. Stage 1, we have 1. At stage 2, here's with stage 1, what do you add? You add 3 more. So here is our stage 2. Let's color it in so you can see. So you add 1 more to each side, you add 3 total. So keep your eye on what stage 3 looks like. So you're going to add 3 to that. So part A says how many new blocks are added to the pattern from one stage to the next? 3. We add 3 every time. So let's look at the table. At stage 1, you had 1. And at stage 2, you have 1, 2, 3, 4 blocks. At stage 3, you have 1, 2, 3, 4, 5, 6, 7 blocks. At 4, you have 10. And at 5, if you added 3 more in a stage 5, you would have 13. So here, you're adding 3 every single time to your y. Remember, x, y. And here, we are adding 1, going up by 1. Stages are going up by 1. Okay, so show where you see the rate of change on the table. I just showed you. That's in the y column, the change in the y. Change in outputs for the y values. Your rate of change is right here. Okay. So let's graph this one. So remember, our y is the number of blocks. And this is the stages over here. Let's again go up by 1, but I'm going to skip All right, so this time we have 1, 1, 2, 4, 3, 7, 4, 10, 5, 13. That's what our pattern looks like this time. This equation is a little trickier to write. Okay, so we need to put it in this format. We know, again, that m is the rate of change and b is the starting point, or the y-intercept, the place the graph crosses the y-axis. But we don't see it on this graph, so let's look at the table. So remember, we're going this way, plus 3, plus 3, plus 3 between each, right? And this is plus 1. If you're going down, adding 1. So what happens if you're going this way? If you go down and you add 1, you go up, you're subtracting 1. So we want to see where at 0, our starting point, how many blocks are there? So we're going to take 1, and instead of adding 3, we're going to subtract 3, which brings us to -2. So at stage 0, that's your y-intercept or starting point. So our equation is y equals 3x. That 3 is this adding 3, and our 2, our starting point, or y-intercept, which is -2, is where you are at stage 0, or where your line is going to hit the y-axis. That one was a little tricky. Okay, so at part F, is this linear? Yes, it's linear. It has a constant rate of change. The thing that's important here is to know is it's not proportional because it doesn't go through 0. For the origin. Okay, let's quickly go over this. We're just going to review what we saw. The geometric model is the one where we added the same number of blocks to each one. So let's say, where do you find the rate of change in all of these? On the geometric model with the blocks, it's how many you add, how many blocks you add. If you're looking at the table, it's the change in the y values on the right side. If you're looking at the graph, it is the slope or the rate of change, how much it goes up. And if you're looking at the equation, it's the m, that's your rate of change. All right, we are going to do a lot more on this. This is just an intro.